As the deep rumble of heavy surface warship propulsion systems echoes almost simultaneously from both sides of the ocean, one a seasoned powerhouse brimming with ambition yet moving with heavy steps, the other a steady yet secretive newcomer. How will this invisible race reshape the rules governing the vast, deep blue? Recent developments in aircraft carrier advancement by China and the United States offer a compelling illustration of this grand question. On one side, the USS John F. Kennedy, the second ship of the Ford-class carrier series, and the U.S. Navy's Great Hope, finally departed the shipyard for its maiden sea trials. Meanwhile, Chinese authorities maintained their customary strategic ambiguity regarding the progress of the much-anticipated fourth aircraft carrier. Yet behind the official statement that we advance carrier construction based on national security and technological development needs, satellite imagery fuels growing speculation. China's next-generation carrier may be transforming from blueprint to reality at an unprecedented pace. The Kennedy Sea trial marks a long-delayed milestone after years of postponements. Construction of this carrier has been fraught with difficulties since its keel laying in 2015, originally slated for delivery in 2022. Repeated delays stemming from integration challenges with new technologies like electromagnetic catapults and advanced arresting gear have pushed the delivery date to March 2027, while costs have soared from approximately $11.3 billion to nearly $13.2 billion. This sea trial marks a substantial step toward its eventual fleet integration. The Ford-class design represents a revolutionary advancement, boasting triple the power generation capacity of the Nimitz class and higher automation levels. However, since commissioning, the lead ship USS Ford has faced widespread criticism over reliability issues in key subsystems, like its electromagnetic catapult and weapons elevators. This casts a shadow over the USS Kennedy sea trials. Has it fully resolved these persistent problems? While the U.S. Navy asserts its design aims to enhance capabilities across the board, actual performance remains to be tested over time. Almost simultaneously, on the other side of the Pacific, China's Ministry of National Defense spokesperson responded to questions about substantive progress on the fourth aircraft carrier with the classic reply, "We are not aware of the specific situation you mentioned." This strategy of neither confirming nor denying reflects a mature strategic discipline. It avoids falling into the rhythm of foreign media hype while shrouding the development of critical equipment in a veil of strategic ambiguity. Yet the scarcity of official information hasn't deterred external observers from tracking developments through alternative channels. Multiple media outlets and monitoring agencies, citing commercial satellite imagery, report that large hull sections are being rapidly assembled at the shipyard believed to be constructing the Type 004 carrier. Analysts predict that at the current pace, the main hull sections could be completed in the first half of this year, potentially reaching launch readiness by year's end. While unverifiable, these unofficial reports collectively point to a possibility: China's aircraft carrier construction, particularly after accumulating substantial technical and craftsmanship experience from the third vessel, the Fujian, is entering a more efficient and streamlined phase. Turning our attention back to the already commissioned Fujian carrier provides deeper insight into the underlying logic of China's aircraft carrier development. This vessel, China's first equipped with an electromagnetic catapult system, did not remain docked for extended periods after commissioning. Instead, it swiftly headed north to the Bohai Sea for intensive, concentrated training. The core objective of this training was clear: to facilitate the Fujian's critical transition from a single-ship technology validation phase to the development of fleet system combat capabilities. The training prioritizes elevating the reliability of the electromagnetic catapult system and the efficiency of carrier aircraft takeoffs and landings to combat-ready standards. The deck has repeatedly witnessed simultaneous operations of J-35 stealth fighters and KJ-600 fixed-wing early warning aircraft, indicating intensive training and launching aircraft of varying weights and types. More significantly, the Fujian, alongside the Liaoning and Shandong, now forms China's three-carrier fleet. This represents not merely quantitative growth, but the nascent formation of a virtuous cycle integrating training, combat readiness, and maintenance. The Liaoning serves as a training platform, the Shandong maintains routine combat readiness duty, while the Fujian focuses on mastering advanced tactical challenges like electromagnetic catapult systems and new aircraft carrier integration technologies. This model ensures China's Navy maintains at least one operational carrier at all times, significantly enhancing the continuity and resilience of its maritime presence. Technical speculations surrounding the Type 004 aircraft carrier have consistently been the hottest topic within the industry. Based on comprehensive analysis from various sources, it is highly likely to represent a crucial step toward the Chinese Navy's goal carrier. The propulsion system undoubtedly remains the primary focus, with most analysts concluding that the Type 004 carries an extremely high probability of adopting nuclear propulsion. Should this materialize, it would mark a milestone in China's aircraft carrier development history, signifying unlimited endurance and significantly enhanced electrical power supply. Its displacement is projected to significantly surpass that of the Fujian-class carrier, advancing toward the 100,000-ton range. Regarding the critical takeoff method, continuing and optimizing electromagnetic catapult technology is almost a foregone conclusion. Some experts note that the electromagnetic catapult system employed on the Fujian class, based on a medium-voltage DC integrated power system, theoretically offers higher energy efficiency and greater system redundancy than the medium-voltage AC solution used on the U.S. Ford-class carriers. The Type 004 is anticipated to carry up to 4 electromagnetic catapults, substantially boosting aircraft sortie rates. Its air wing will comprise a formidable force, centered on J-35 stealth fighters, J-15T catapult-launched heavy fighters, and KJ-600 early warning aircraft, potentially integrated with unmanned combat aerial vehicles. Naturally, as China's first domestically built nuclear-powered carrier, the reliability, safety, and integration efficiency of its reactor with the hull represent the most significant technical challenges requiring time to validate. Thus, a three-dimensional picture of the U.S.-China aircraft carrier race, both in speed and quality, is gradually coming into focus. America's advantage lies in its half-century of nuclear carrier operational experience and vast active fleet, with the Ford-class design philosophy still representing the future direction. Yet its challenges are equally pronounced. Overly aggressive integration of new technologies has caused severe project delays and cost overruns. The decline of domestic shipbuilding infrastructure has hampered construction efficiency, and the subsystem reliability issues exposed on the USS Ford will require substantial time and resources to resolve on subsequent vessels. China's approach appears more prudent and efficient, progressing from mastering fundamentals through the Liaoning's retrofitting, to achieving full process integration with the Shandong's construction, and then making a technological leap with the independently developed electromagnetic catapult-equipped Fujian. Each step has been methodically executed while substantially enhancing the nation's shipbuilding industrial system. This model of incremental, iterative advancement has enabled China's aircraft carrier construction pace to significantly outpace its currently troubled American counterpart. More importantly, through the rapid combat readiness of the Fujian, China has demonstrated its engineering capability in applying electromagnetic catapult technology, a top-tier carrier critical technology. Thus, this race extends far beyond who launches the next giant vessel first. At its core, it represents a comprehensive contest of national industrial capacity, technological integration, and strategic patience between the two nations. The U.S. seeks to cement its lead through a single technological leap, yet faces complications in the complex waters of deep-sea systems engineering. China, through sustained, incremental investment and experimentation, is systematically narrowing the gap and beginning to demonstrate distinctive capabilities, even localized advantages, in specific domains. The Type 004 carrier, regardless of its final form, will epitomize this systemic enhancement of China's capabilities. Its emergence signifies more than just another addition to the Chinese Navy's fleet. It marks China's imminent ascent to a new pinnacle in the complete design, construction, and operational chain of advanced aircraft carriers. For the U.S. Navy, the sea trials of the USS John F. Kennedy represent a belated piece of good news. Yet its true concern may lie not in the comparison of any single vessel, but in the unstoppable, systemic momentum of its rival's rise. As modular construction accelerates in eastern shipyards, and new carrier-based aircraft repeatedly pierce the sky propelled by electromagnetic catapults, the balance of power across the oceans is undergoing silent yet profound shifts, unseen within our dry docks and unheard within our data links.